in today's session, what we're going to do is take a look at the data modeling that needs to be done in Power BI before we can start making those visualizations. Now, Power BI can do some modeling on its own based on the data that we're extracting. So it uses its own intelligence and produces a data model, but we may have to go and explicitly change some kinds of relationships in that model for our visualizations to work perfectly. We have these three panes over here, and we can just click on the first one, that is your charts. If you click on the second one, that is going to be your data, and you can see the 4 tables that were imported from that spreadsheet. So basically we had some orders data. So these are orders. So I've just kept a small number of orders, and then we had some other tables like the category, the customer, and the product. So if we now go to the third option over here, which is models, and click on it, you can see that some model has been created by Power BI itself. So now let's just put the properties in and hide the fields as well and fit this to the view. We can arrange it a bit so that we can see it much better. And now we can increase the font. All right. So now you can see that there has been a data model that Power BI has created based on all these tables and the data that we imported. So it is a data model, and data model, if you're aware, in terms of any relational data model, we have different kinds of relationships between tables, and the relationships define how the data is to be joined between the two tables, or how the data is related between the two different tables. For example, we have the orders here. Now in orders, we have some data relating to each order and the customer that has given that order. So to relate it to the customer table, we have a field called customer ID, and that is able to relate it to the customer table over here that also has that column called customer ID. Similarly, orders are based on some products which can be found in the product table, and we can define a relationship between the orders and product based on that product ID. And then this is like a snowflake schema where you can go down a level or go up a level. So you have the category, which is up a level than the product, and then you have these products at a lower granular level, and we have defined a relationship between them. Now we can see this is one and this is star, which basically means it's a one-to-many relationship. So there are different kinds of relationships. There can be a one-to-one relationship, there can be many-to-many relationships, and then there is a one-to-many relationship. A one-to-many relationship simply means that for each category in this item, there can be multiple products which are associated. So this is one-to-many because one category can have multiple products over here, but each product over here can belong to only one category over here. So from this side, from the product end, it's a one many to one relationship, because multiple products can lie in one category, but each product can belong to only one category. So this is what a one-to-many relationship looks like. And this arrow button has a particular direction, and in all the cases, it is flowing from the one to the many relationship. Now, to begin with, let's say we have data from multiple sources, or we keep on adding data, or even if it's an Excel data source and not a proper database, then sometimes Power BI cannot detect the relationships between tables. So it will leave the relationship. There won't be any relationship defined, and you will have some standalone table that you would be able to see here. So for that, let's just go over here and assume that Power BI was not able to find this relationship. So let's just go and delete this relationship for now. And now there is no relationship defined between the orders and customer table, and customer is like a standalone table in this data model. So sometimes this can happen that Power BI will not be able to identify the relationships on its own, and there would be standalone tables. And now we need to go and specify the relationships explicitly. So now there are two options to do that. We can just go over here and go to manage relationships, and when we click on this manage relationship, this pop-up will come up, and in this pop-up we can already see the active relationships. So we already have a relationship between the orders and product on product ID and product and category on category ID. Now you can see that the different options over here, we can edit these relationships, make it on different column probably, or make them inactive. We can even delete these relationships if we think that these are not right for the visualizations that we want to do. And then there's an option to auto detect as well. So auto detect is basically asking Power BI again to use its intelligence and detect the relationship based on the data that it sees and the structure of the data that it sees in the various tables that we have imported. So if we just say auto detect, because in our case, in the very first attempt itself, Power BI was correctly able to identify the relationship. So if we say auto detect, uh, it will be able to find one new relationship which we just deleted. So it is able to identify that relationship, and we can just say close, and it is going to add that relationship over here at the very top. We can see that a new relationship has been added, which is between the orders customer ID and the customer table customer ID. So now it is able to detect the relationships on its own pretty much most of the times. Sometimes in the Excel workbooks, it is not quite possible to detect the relationships. Mostly if you're working with databases, it will be able to detect the relationships because the relationships are defined and databases are designed that way. So it is easily able to define the relationships and detect them. But if it is not, then we can use the auto detect feature, and once we use the auto detect feature, it will create a relationship again from the one to many side we can see, and the direction is, or the data is flowing from the one to many table. Okay, so now that we have all these relationships defined on these tables, let's see how they work and how we can edit these uh, relationships. So let's just go over and create some simple visualizations to see how these relationships actually affect the data that would be pulled in the visualizations. So for now, we have simple one-to-many relationships between all the tables. The master table is the orders table, and we have some product data and customer data. And then we have a category table, which is kind of a snowflake thing. So let's go back to our report view. And as we go back to the report view, we can see that there is the option of various visualizations. Let's increase the size of this. So I'm just going to increase the page view to actual size so that it's a little bigger. Back to the home pane. Okay. We are not going to use the filters for now, so let's just hide them. Okay, so now what we're going to do, simple visualizations. Let's see and see how the filters and the relationships are working. So let's say we just want to view the sales. So bring in the sales, and we want to view the sales by product. So let's say product name. Okay, so here we can simply see that there are some values of the sales. You can see uh, the sales values which are categorized by the different product names. So this seems all right. Let's go to another page, and now let's see the same thing, sales by, let's say, in the customer table. Let's pull the city from the customer table. So if you pull the city, make this a little larger, we can again see that the sales has been now categorized by the city. So the relationships are working fine. I am getting separate and distinct values as per the sales which happened in that particular city. So this seems to be working fine. Now let's go and build another visualization where we are going to see the sales, again sales. And in this case, we are going to see both by the product and the city. So let's pull in the city, and from the product table, let's pull in the product name. So these are simple bar charts. You can see now it is giving some value like this. So let's make it into a table for easy viewing. So this is going to be your table. Let's go and increase the text size a bit. We can increase the text. Okay, so now we can see the values that there are uh, like they are categorized on the combination of city and product, and these are the different sales values on this particular combination. So everything seems to be working fine till now. But now let's say we have a requirement where we want to find out the number of customers that place an order for a particular product. So we want to find that out. Okay. So for that, the very first step would be to create some new measure that would be able to take or perform that count of the number of customers. So we need to create a new measure before we go on and create a new visualization. Now, this is a way of enhancing your data model by adding new measures to your data model. Now you can see that there are various options right in this pane. So even from the report view, we can just go on the top over here, and there's an option here to add a new measure. When you hover over it, you'll see that it simply says that you need to write a DEX expression that calculates a value for your data. And DEX expressions are what you would need to write for Microsoft Power BI to create customized calculations or customized measures whenever you are creating, or any kind of calculation. Whenever you write, it would be a DEX expression. So there is a whole lot of theory on DEX and the DEX functions itself. It's a very powerful language, and we'll go into one session where we'll explicitly explore a wide range of DAX functions which are useful in terms of writing your code. So for now, we're just going to click on new measure over here. And when you click on new measure, it will give you a window like this where you can see we have gone to the measure tools, and this is your name of the measure. This is the home. Home is basically the table in which the measure would reside. So you can change that place. So the measure that we are creating, and this is your formula box or the expression box. So the measure that we are going to create is basically the count of employees. So let's just call it, sorry, count of customers. Let's just go back and change this name to count of customers and equal to, and now we are just doing the count of the customer IDs or customer names. So as soon as you would begin typing the kind of function that you're looking for, Power BI would suggest all the possible functions that exist for that, and you can just select that function if you're not sure of how it exactly works and what is the difference between, let's say, count and count A. Then if you just select that particular function, you'll be able to see. So the count, as you can see over here, counts the numbers in a column. Count A instead counts the number of values in a column. So we are not interested in counting the numbers in a column. We are interested in counting the number of values in a column. And we can even go for a distinct count in a case. So it will count the number of distinct values in a column because the customer might have placed an order for the same product twice. So let's just go and say that we want to count the distinct number of values in a column. So we are going to use this function, and you can just double click on it, and that function would be inserted over here. And now it is suggesting the syntax. So it is asking for the column name based on which you want to count, and it is giving you the list of column names that exist based on your data. So we have to count based on either the customer ID or the customer name. So let's say customer name for now. A better thing to do is customer ID, because that way we'll be sure that it is going to be a unique value. Okay. And then just close your brackets and say this, and your measure would be created. And if you go over here now, because this has been created in your home table, which is category, let's change this to customer. So just go to your home table on the drop down and select the right table which you think is best suited for this measure. Now changing the table would not have any effect on the calculation that is getting performed using this measure. It can reside anywhere in this fields pane and it would still compute the same value. But it is more for our understanding and better grouping of these fields on the right hand side. So we are going to put it under customer so that it's easier for us to find it when we want to. So now we have a count of customer created over here. Okay. And our main intention all along was to find the number of customers who ordered for a particular product. Okay, so now we are going to go and create a new visualization to achieve this purpose. So, okay, we said that we want to find out the product name. So let's bring in the product name over here. and we want to find the number of customers. So we are going to use our measure that we created, which we can see over here. It is the count of customer measure, and just drag and drop it over here. Okay, so now if you can see, let me just increase the text size again. Now if you can see over here that we had total of 9 customers, and it has given you a count of 9 for each of the products. Though we said that we want to find out the number of customers who placed the order for this product, but it has given us a flat count. That means it has not created its summation or count based on these categories that we defined over here, or based on the product names in our example. So what is wrong in this case, and how can this be fixed? Now this is where we realize the importance of defining the right relationships in the data model between the various tables that we are working with. So to fix this, we have to go back to the data model. Once we go back to the data model, we have to select these relationships between orders product and orders customer, because something is wrong definitely over here, and that's why we have got the wrong result. So you can just double click. So let's see what is the relationship. If we want to see details of this relationship between orders and product, so we can just double click on this, or you can go through manage relationships and select the edit option. But if we just double click, we'll enter the edit relationship window, and that just gives you a preview of the orders data, of the product data, and you can see the field on which the join has been performed has been highlighted, which is the ID. So all this is fine so far. The next thing that is being done is many to one relationship, which seems to be okay in our case, because that is the case for us. It is going to be a many to one relationship. But now there's something over here which we can see, which is the cross filter direction. Now the cross filter direction, if you just go and click on the drop down, you can see that there are two options over here, single and both. And currently the option that is selected is single. And that is why you see this kind of a single arrow on the relationships here. So for all the relationships in our data model, the relationship has been selected. The cross filter direction for the relationship has been selected as a single arrow. Now this cross filter direction is very important, and it defines the way your data will be filtered. So from in which direction, from which table to which table, the data would be filtered. Now, if we do not alter this and try to understand why our count did not come correct in the previous visualizations, and now let's take a look. Now, if you just go by the arrow and the direction in which the arrow is going, it is basically going from products to orders. So data is flowing from the product to orders, and that's why if you perform any calculations based on any of the columns in orders or product, that is going to give you correct results. And similarly, data is flowing from customer to orders, and that's why you perform any calculation based on any of the columns, which is already there in these columns, in these two different tables, then it is going to give you correct results, because they are related to each other and data flows between these tables. But if you take a look at the arrows, now the data is flowing from the product table to the orders table, but the data is not flowing from the orders table to the customer table, because the direction of this arrow is from the customer to the orders table, right? But now what we are trying to achieve is we are trying to find a count of customer for each product. So we are trying to establish some relationship between the product and customer. So there has to be a way that data flows from this product table to this customer data table. But this is not happening because of the direction of these filters, because the flow is getting broken over here. The flow is from product to orders, and then from orders it is not getting till the customer table, but the flow from the customer table till the orders is also established. And that's why if you just perform any visualization from the data from these two tables, it is going to be correct. So we need to change this, and the way we can change this is again by editing the relationship and changing the cross filter direction to both. So now the data can flow between the various tables over here, So it flows in both the directions. So the data can now flow between product orders, and we need to change the direction over here as well to both. And now the data can flow and the filters can be applied from the product table on the customer table, or from the customer table on the product table, because now we have specified the cross filter direction in both the directions. So the filters can be applied in any direction. Now let's go back to our visualization and see if it has fixed the issue that we had earlier, and it has correctly fixed the issue, as we can see over here. So now it is giving us a distinct count for each product name. So now the filter has been applied on the count of customers based on the product name, because we changed the direction of the filter to both. So now the data and the filtering logic can flow from the product table, from the orders till the customer table, and vice versa. So for requirements like these, you have to be careful, and you have to go and change your relationship types if they have been detected only as single uh, direction relationships, as was detected by Power BI in our case. Then you have to make sure that your relationship types, first of all, the types, whether it's defined to be one is to many or should it be many to many. Okay, and then you have to focus on the direction of the cross filter, because it's very important in the way your results would be fetched. So what kind of visualizations you want to perform, what kind of categorization you want to perform in your visualizations for now and for later on, based on that, you have to define your cross filter directions. Okay. So this is how defining your relationships affects the data in your visualizations and why it is so important. Now, one thing that might be coming to your mind is, um, it's then so simple. I mean, we do not even have to think, just go and define all the relationships as bidirectional. So that should solve our problems in most of the cases, even if we are not performing any visualizations or any filters between the products and customers tables, and we do not foresee any use or requirement even in the future. I mean, we can just have it, because even if we have the cross filter direction as both, I mean, the join between the product and orders would still work. So things would still work in terms of fetching the data and the visualizations. And it is easy, and we do not have to think, just go and change all the filter directions to bidirectional. But that is not what needs to be done. So we have to be careful over here. And what is the reason that we do not want to do that? The reason is that though it is very tempting and easy to go and just change all the filter directions to cross directional as both in for all the tables and for all the relationships in a data model, the both or the bidirectional filters have a high performance penalty. Okay, so we do not want the visualizations to have any performance issues. That is the most primary concern in case of visualizations. They have to come up quickly. The data needs to be refreshed quickly. So we do not want to unnecessarily add any bidirectional filters. So again, we have to be very careful and add these bidirectional filters only when we are absolutely sure that we want them and we need them. Okay, otherwise we do not need to change our filters to bidirectional, but it would be a mix of bidirectional and single directional filters based on the different tables that you have in your data model. So you have to be careful again, because all these bidirectional filters are going to have a high performance penalty.